Alright, this is Chapter 1 for 6th grade math. Number sense and algebraic thinking is Chapter 1. We got about 7 units in this. So first today we're going to do 1.1. You've already worked on some prerequisite skills on page 2. Just going through some vocabulary and doing some skills, just vocabulary like sum, difference, product, quotient, those types of things. Whole number, those are some of the vocabulary that you're going to be seeing. So we'll get those down and take some notes on those. So if you would get your 2-column notes ready and just put key vocabulary and write these vocabulary words on there. As we go through, we'll go back and we can put in some information about them, or you can as you take notes, what the sum is, difference, product, and quotient. So let's move to the next slide. We have in 1.1 whole number operations. Example 1 talks about adding whole numbers. So as you can see, to find the sum of 954 and 78, you line up the numbers on the ones place. So notice the 4 and the 8 are in the ones place, so they're lined up. The 5 and the 7 are in the ones place, so they're lined up. Let's see if I can get my screen to go here. And then you add the ones, so 4 plus 8 is 12. So regroup the 12 ones as 1, 10, and 2 ones. So your 2 gets written down and you carry the 10 ones. It's carrying over to the tens place, so that 1 means really 110. So then you continue and you add the, get my pin going here. You add the 7 and the 5 right there, right here. And that comes out to be 13 when you add the 1 with it that you carried. Regroup the 13 again, you carry over the 1 on the top up here. You can see right there we carried. And we go back to the next and you finally then add. So let's add 95 plus 37. So you got to practice in your notes, you write this. We put 95 plus, ooh, you gotta bear with me, I'm not, sometimes my stuff cooperates and sometimes it doesn't. So let's go forward here. Let me see here, let me just do this. 95 plus 37. Okay, notice I've lined up my ones right here and I've lined up my tens. So first thing we're going to do is we're going to add the ones. 5 and 7 is 12, and that's just a basic fact that you should know. I regroup by carrying that 10, and you know, I always look for groups of 10, so I'm going to add the 9 and the 1 first and get 10 and the 3, and so it's 13, 132. So just remember to line them up nice and neat, add them, and then it goes great. Second one here, 44 plus 87. Let's see if I can do this a little bit neater. Okay, so I'm lining up my ones, I'm lined up my tens. I always add the ones first. 7 plus 4 is 11, and then I carry the 1 up here. 8 plus 4 is 12, plus 1 is 13. So our answer is 131 when we're finding the sum. So we go to the next one. 406 plus 95. Now I'm trying to mess with a little here because I'm going to put the 400, you know, it doesn't matter which order you add in. I'm going to put the bigger number on top. And I'm going to line up these numbers with the ones in the tens place. So we just go through again and we add. 6 plus 5 is 11, carry the 1. 9 plus 1 is 10, carry the 1. 4 plus 1 is 5. So 406 plus 95 is 501. So next one on the guided practice, which is the last one for this, is 614 plus 196. Now notice I've tried to line them up. It's, again, my ones, my tens, and my hundreds. So 6 plus 4 is 10. Carry the 1. I got 9, 10, 11 in the tens place. And then 6, 7, 8. So I get 810 when I find this for the sum of 614 plus 196. Notice, if you go back to your vocabulary, we're using the sum And if you're noticing, sum is the word that means to add. So you want to add that into your notes on sum, so you know how to do those. So let's move on to the next thing. So example number 2, I'm on page 4 in the book, actually the top of page 4, subtracting whole numbers. So check this out. To find the difference of 204 and 36, you line up the numbers in the ones place just like you do when you find the sum, and then you subtract the ones and the tens and so on. So let's take a look at how the book does this. You'll notice first thing they did is they lined their numbers up. Second thing they did is you look at the ones place, and you'll notice that there was not enough right here. You can't take 6 away from 4. So we got to make that 4 bigger. So we go next door and we try to borrow. We're going to try to borrow a 10 from it. Well, the 0, there's nothing to borrow. So we got to go all the way over to the 2. Notice they crossed out the 2 and put a 1. Then this became a 10. They crossed it out. It became a 9. Now we have 10, which is 14. It gets a little confusing with the subtraction. So let's see what else they did here. We'll go down here to the... So you'll see they take 14 minus 6 then and get 8, which is just the ones place. We made that a 14. And then they took 9 minus 3, which is 6 in the tens place. And then the only one left is the hundreds, which is 168. And what's kind of cool about subtraction is you can take the answer that you got, 168, and the answer that the number you were subtracting, and add those, which is the same skill that we just finished up doing, 6, 7, 8, 9, 10. And those two numbers should equal that top number. So you can always check your subtraction and see if it's right. And I kind of do a quick mental check. I will just kind of add these numbers right here up and see if they match the number up there. So just a little trick so you don't make mistakes. So let's check out example number 3. It talks about multiplying whole numbers. So you're going to take music lessons. Your music lessons cost $25 per week. How much will you pay for 12 weeks of lessons? So every week is $25. So one way to do, I see lots of, there's all sorts of ways to do this. One way is to just take 25 times 12, because you're going to do it 12 times, $25 each time, 25 times 12. So look at what they did. They have them lined up. So when you multiply, you multiply the ones digit, so you have this 2 and this 5 right here. So you multiply right there. So if I can write on here, you multiply those numbers. So 2 times 5 is 10, and then you carry the 1. So you can see they'll probably do that better than what I did. Check this out. And then the 1 times the 2. Let me go back here. 5 times 2 was 10, and they carried the 1 right there, right here. And 2 times 2 is 4, plus 1 is 5. So we took the 2, we took the ones digit right here times this number, then times this number. So we'll talk about other ways to do it. Let's see what they do here. They're explaining it there. Let's see. Then they do the same thing for the tens. Right here you have the blue, that's why they have them color coded. 1 times 5 is 5, and notice they have it kind of scooched over. I always put a placeholder right there, a 0, just so I don't accidentally scoot that other 5 over. But the reason why they do that is because we're now multiplying by the tens digit. So 1 times 5 is 5. That 5 goes under there, straight under where that digit is. And then 1 times 2 is 2. So then we get ready to add, and you'll see right here, go back here, sorry, then the answer is 300. So that's one way, is to do just the regular algorithm of a 2 by 2 digit multiplication problem. Another way, let me see if I can fit this in right here. Another way is to just think quarters right here. Think quarters. I know it takes 4 quarters to make 100. or 4 quarters to make $1, or 4 $25 to make $100. So every 4 25s is 100. So how many 4s are in 12? 3. So that would be 300. So when the numbers are easy, like quarters, I think quarters are easy. You can look at different ways to help you do those. Another way to do this is, let me see if I can remember, or if I can draw it, is called lattice multiplication. You make it's a 2 by 2, so you put 25, you make a box that has room for each of the numbers, like this, and this would be 12. And you put diagonals in all of these. Let me see if I can draw them without it being a mess. And then you go through and you multiply. You just take, these are like where they would, if they were to come together and join. So this would be 5 times 1, this box right here. 5 times 1 is 5, so you put a 0 and a 5. This box, 5 times 2 is 10, so you put a 1 and a 0. Over here, the 2 would come down and the 2 would come over, so 2 times 2 is 4. Put the 4 right there. And this one is 2 and the 1 would come over, so 2 times 1 is 2. So you put 0, 2. Then you forget about the numbers on the outside, you only deal with the numbers on the inside of the box, and you start to add the diagonals. So this is a 0. These come out to be 10. And you carry just like you normally carry when you add. 2 plus 1 in this row or diagonal is 3, and that's just 0, and no number starts with a 0. So there's your answer, 300. Lattice is kind of fun. If you struggle with the old algorithm, lattice multiplication is fun. If you want to know more about it, you can ask me, and we can do a couple more problems together if you'd like using lattice. So again, here they are, finishing up with the answer saying that we would pay $300 for 12 weeks of music lessons. So example 4, dividing whole numbers. It seems to be this is the thing that scares most people, is dividing. You know, dividing is just taking something and splitting it up equally. A lot of times I think of it like money. Quotient, again, I didn't do very good with vocabulary on the last, let me see if I can back up. They probably use the word, I don't know if they use the word right here, product, right here. Okay, so there's a vocabulary word. Product means to multiply. So we'll go back to this other one we're doing now. We have quotient. So right here, quotient right here is the fancy word that means you divide. So find the quotient of 592 and 7. And a lot of times I think of it like this. You have $592 and you're going to split it up with 7 people. How much money are you each going to get? So it says you can use long division. So let's see what they do in long division here, how they. So there they are, writing it as a division problem with the answer. Actually, these have some special names. This number right here is called the dividend. And I always say dividend in because it's in the box. Dividend, in, dividend. And then the 7 is called the divisor. That's what we're dividing by. So that's how many people or how many things you need something split up into. So we go down to the next one here. So we just start dividing. First we see, can it go into 5? 7 can't go into 5, so we have to take 7 into 59. And there's where multiplication comes in. I always think, what number times 7 is close to 59? Well, 8 times 7 is 56. 9 times 7 is 63. 9 would be too many. So we would put an 8 above the 59. And maybe, okay, so we put it above the 9, and notice where it says to line it up. You multiply, 8 times 7 is 56. You put that under the 59. You subtract. 59 minus 56 is 3. Bring down the 2. And you just keep going. Now you're going to take 7 into 32, which goes 4 times, which is 28. And then you subtract, there's 4 left over. So 84, remainder 4. So if that was money, and there were 7 of us, we'd all get $84, and then there'd be some left over for us to fight over or something. I don't know. So let's practice these. Difference, I don't know if we talked about that word as far as vocabulary in your notes. Difference, you want to define that as the answer to a subtraction problem. It means to subtract, so make sure you put that in your work right there. So let's do this one, 95 minus 37. So you're doing these with me. I've lined up the ones, we've lined up the tens. So you'll notice we can't take 7 away from 5. That top number's got to be bigger. So we're going to take and borrow a 10 from the tens column. So we're going to make that an 8. We're going to borrow 10, so that's going to become a 15. Now some people just put a 1 and make it look like a 15. Some people will put the 15 up there to remember. So now 15 is bigger than 7, so 15 minus 7. And I don't think subtraction, I think addition. I think what number plus 7 gets me 15, and right away I know that's 8. And then we go to the ones or the tens, and we're good. 8 minus 3 is 5. And again, we can check our work. 58 plus 37 should be 95. Let's see if it is. 8 plus 7 is 15. Carry the 1, that's 8 plus 1 is 9. 95. Works out great. So let's do another one here. 82 minus 49. Okay. We look at the ones, so we can't take 9 away from 2, so we have to go over to the 8, make it a 7, and borrow. This becomes a 12. 12 minus 9, 9 plus 3 is 12. 7 minus 4 is 3. That one's easy, I can remember that one. So 49, let's check our work. Plus 33, let's see if it works out. 2, carry the 1, 4, 5, that would be 82. Alright, so there's some subtraction problems for us. And a couple more, they're trying to throw some zeros in there, which makes it a little bit harder. So we look at the ones, we're good. Look at that, 6 minus 5, that works out great, that's a 1. We go over here and we can't subtract 9 away from nothing, from 0, so we take the 4 and it becomes a 3. We add this over here. Actually, we're borrowing 100. We get 10 minus 9, which is 1, and then 3 minus nothing is 3. So we're good. We're good to go there. And that 100 became 1010, so that's why there's a 10 right there. So let's check it. 311 plus 95. That's 6, 0, carry the 1, 406, which is what over here, what we started with, which is perfect. Okay, now check out this one. We've got some zeros here. So we look at this, and to do the algorithm of subtracting, we can't take 5 away from 0. So we go over here to borrow. Guess what? Nothing there. Nothing to borrow. So we go again, and so I'm going to cross out that 5 and make it a 4, which would make this, I always just put, make this the 10, which then becomes a 9, because we got to borrow from it, and this becomes a 10. So 10 minus 5 is 5, 9 minus 1 is 8, 4 minus 3 is 1. So let's see what we got there. I'm not writing very good with my pen. 185. 0, carry the 1, 8, 9, 10, carry the 1, 3, 4, 5. Okay, so it's good. That's supposed to be a check mark. It checks. Yay. We're good. Woohoo! Okay, so let's see what they have in store for us next in the guided practice. Find the product or the quotient. Well, remember, product means the answer to a multiplication problem. So this problem right here is the product problem. So we do 29 times 31. Okay, my pen is acting up for some reason. It's probably operator error. Let me see here. Let's go over here. Let's try it again. 29 times 31. Okay, so the old algorithm, we start with the tens, or the ones place. 1 times 9 is 9. 1 times 2 is 2. put a placeholder because I got to go to the tens. 3 times 9 is 27, carry the 2. 3 times 2 is 6, plus 2 is 8. And then we take those and we add them. 899. So, we can see maybe let's check it with our lattice. Let's try that. Let's go my boxes. I can't without my pen going crazy on me. Diagonals. Let's see, let's put 29 right here, and let's put 31 right here. So, bring our numbers in. 9 times 1 is 9. 2 times 1 is 2, and all I'm doing is bringing these numbers in. 2 times 3 is 6. 9 times 3 is 27. And then we add the diagonals. Forgetting about the numbers on the outside, it's just the numbers on the inside. There's the 9. This diagonal is 7, 8, 9. There's another 9. 6, 7, 8. 899, which is what we got right there. So we're good. Okay, the next one. Let's check it out. Another product, 140 plus 15. Now there's a couple of ways to do. There's some shortcuts. 140 times 15. You can do the regular old algorithm, and you could take 5 times 0 and get 0, 5 times 4 and get 20, carry the 2. 5 times 1 plus 2 is 7, add your placeholder. 1 times 0 is 0, 1 times 4 is 4, 1 times 1 is 1. And add those up, 0, 0, 11, carry the 1, 2100. Or you could take the 0 off of the 14 and just do 14 times 15. And that'd be 7, placeholder 4, 1. 0, 1, carry the 1, 2. And that 0 you took off, you got to put back on. You could do lattice. Let's see if I can squeeze it in here. I have a 3 by 2 box now, so I need to make room here. So I'll make my diagonals. And I put the 140 up here because that's where I had room for the 3 numbers. And I put 15 right here. 0 times 1 is 0. 0 times 5 is 0. 1 times 4, notice these where these numbers, if they were to walk in and meet, and then you multiply them, whoop, that's a 0, that's a 4. That's a 4 and a 5, there's 20. 5 times 1 and 1 times 1. Now we add our diagonals, we get 0, 0, 7, 8, 9, 10, 11. Carry the 1. And 2. 2100. So there's some product work. Let's see if they have some quotient stuff for us here. We got some dividing. Ooh, here we go. 721 divided by 6. So 721 is the dividend. It goes in the box divided by 6. So in other words, $721 split up with 6 people. Start dividing, we take the first number and we just take number by number. Can 6 go into 7? Yes, it goes in there once. Remember, you're doing these problems with me. We subtract 7 minus 6 is 1, and you bring down the 2. Can 6 go into 12? Yes, exactly 2 times. And we keep bringing down numbers till we run out of numbers. Now, can 6 go into 1? No. That's a 0, and they can't do it anymore, so it's just remainder 1. So we'd have $120 each of us if that's what we're going to split up money-wise. Check division. The opposite of dividing is multiplying, so we take that 120 times 6, which would be 0, 12, carry the 1, 720, and then the remainder you add on. That's supposed to be a 2 right there. So that would be 721. So we would know we got the right answer when we divided. So, ooh, they're going to give us a little harder one. 418 divided by 21. So we look and we say, can 21 obviously can't go into 4. Can 21 go into 41? Well, 2 21s is 42, so that's too many. So we got to take 21 into 418. I don't know how many times 21 goes into 418, so I go over here to the side, and you know, I know 20 times 5 is 100, so I know it's got to be more than 5. Let's try 8, just as a starting point. So I get, no, wait a minute, I'm not doing that right. Whoa, back up. Whoa, I'm losing my mind, you guys. Whoosh, sorry. 21 does go into 41. It goes in there once. You guys catch that? Whoa, back it up. There we go. So then there's 20 left over. Wow, I caught it when I was trying to get 21. I couldn't get it to work, so I knew I messed up somewhere. So, see? First mistake I made on this podcast. Bring down the 8. Because 21 won't go into 20. I know that one for sure. 21 into 208. Now I'm going to try my 8. That's 168. So I'm going to try it again times 9. 189, and see, times 10. You can't do 10. That would be 210. That would be too many. So it's going to go in there 9 times. So up here you're going to put a 9. Down here you put that answer, 189. We subtract, and notice that subtracting is coming in handy, what we just practiced. I can't, so I got to go over here and borrow. Make that a 9. 18 minus 9 is 9. 9 minus 8 is 1. So it's going to be 19 remainder. 19. That's kind of neat how that turned out. So anyway, and so let's see what's next on this. Alright, example 5, interpreting remainders. You know, you divide just like we did, we got that remainder 19. Sometimes we got to know, now according to the problem we're solving, what does that remainder mean? So check this example out. Framing. You plan to construct wooden photo frames. You need 50 centimeters of wood for each frame. You have a total of 275 centimeters of wood. How many photo frames can you make? So basically, we want to know how many 50s are in 275. So you'll notice the first thing that they do is decide we need to divide to find it. So there's our division problem, and you go through and you do all the steps of dividing, but notice there's a remainder. So we have that remainder, we have to interpret it. That means we have to understand, what does the remainder mean? Is there going to be enough to make another frame? What are we going to do with that? So 5 remainder 25. The 5 means we can make 5 whole photo frames. There's 5 50s, 5 whole ones, but there'd be 25 centimeters remaining. Remember, it takes 50 to make the frame, so we would just have extra. So we could not make another photo frame, so we would only be able to make 5 with some left over. Now, in math, a lot of times there's a lot of things with patterns, with numbers. So notice on example 6, it's called Finding Patterns. It says the Summer Olympics were held in 1992, 1996, 2000, and 2004. Describe the pattern, then find the next 2 years in the pattern. So notice if you look at the numbers, it says look at the how each number is related to the preceding number. Preceding means the number before it. So from 1992 to 1996, there's a difference of 4. Then from 1996 to 2000, that's 4. 2000 to 2004, that's 4. So every time the years are going up by 4. So notice they put a plus 4. So the next 2 years would be 2008 and 2012. So let's check out this guided practice now. It says you are setting up tables for a banquet for 100 guests. Each table seats 8 people. What is the minimum numbers of tables that you will need? Well, as you go through, and we're looking at this, we are taking 8. We have 100 people, and each table seats 8 people. So how many 8s are in 100 will tell us how many tables we need. So we take 100 and we divide it by 8. Well, so let's see how many tables that'll work. 8 goes into 10 once. We subtract, we get 2, which we bring down that 0. 8 goes into 20 2 times, which is 16. And we have a remainder of 4. So I have remainder 4. So you'll notice that 12, remainder 4. We need to interpret that for our answer. This means 12 whole tables. There'll be 12 tables with 8 people at each table. And remainder 4 means we have 4 extra people, but they still need a table. So in this problem, we would need to put 13 tables. Even though one of them wouldn't be totally full, the other people still need a table. So in that case, we would use that number and round that number up. Remember, with the photo frames, we didn't have enough, so we had to round that number down. The next guided practice has some patterns. So you'll notice, find the next 2 numbers and describe the pattern. So here we go through 1, 4, 7, 10. We look at the relationship, and you will notice that it's going up by 3 each time, so the next 2 numbers would be 13 and 16. So in describing the pattern, you would say add 3 each time, goes up by 3 each time. This one, you'll notice the numbers are going down. 55, 50, 45, 40, so we're at minus 5 each time. So the next answers would be 35. 35 and 30. Sorry, I got crazy click in there. The next one, number 16, and you're writing these down with me or as I'm doing these, we look at this and we see, okay, from here to here, it's plus 3. From here to here, it's plus 6. From here to here, it's plus 12. So it's a little hard to tell on the adding. It's got a pattern to the adding. It's doubling each time. So when I say doubling, a good number for doubling is 2. So that would be times 2. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 would be 48. 48 times 2 would be 48 times 2. How come I can't think of it? 100. Let me just do it twice. Would be 96. My brain isn't working. All right, so let's see what they say. I don't know if I have the answer for this one. Yay, look, I got it right. Woohoo! Okay, on number 17, last one on the guided practice. Notice this time now it's going down. So I noticed before when it was going up and the numbers were a little different that I multiplied. This one, I'm just going to make a guess that we might divide. I'm looking at the 80 and the 40. I'm going to pick the easy numbers to look at here. You don't have to always go in order. I'm going to look at these numbers, and the difference is half. So did they cut those in half, divide it by 2? Half of 160 is 80. Half of 320 is 60. So I'm going to say, yeah, this half of 40 is 20, and half of 20 is 10. So let's see if they came up with the same thing. Sure enough, the answers are 20.